Plan is to let her do it all. Okay. All right, so let's talk about this. When we had started setting it up yesterday, we figured out u, and then we figured out what dx was the equivalent of 1/2 du. But we ran into this problem where we had this extra x. And because we wanted to integrate with respect to u, we had to change all of our x's to u because we can't integrate x with respect to u. There is no implicit integration, at least not really in this class. Maybe in Cal 2 you kind of start to hit on that idea a little bit. But we had to change this x. So we said, okay, well, if u is 2x minus 1, then 2x would be u plus 1. So x is 1/2 u plus 1. And so we can take that 1/2 u plus 1, substitute it in for x, and then we rewrote our integral. And then you guys were supposed to take it from there. I reminded you that we needed to pull out both of our constant multiples. So we pulled out both 1/2s. And then that left us with u plus 1 times u to the 1/2. And then I think I also told you guys you could distribute that. And that's where you guys took over. So we have u to the first times u to the 1/2. If we add the exponents, 2/2 plus 1/2 gives us 3/2. Here we've got 1 times u to the 1/2, which is just 1/2. Then, again, leaving our constant alone, add 1 to the exponent. So 3/2 plus 2/2 is 5/2. Divide by that exponent. 1/2 plus 2/2 is 3/2. Divide by that exponent. And always remember the plus c. Dividing is the same thing as multiplying by the reciprocal, so I pulled those out, and instead of dividing by 5/2 and 3/2, we multiplied by 2/5 and 2/3. And then I distributed 1/4 back in. So the 2 and the 4 cancel, so I have 2 times 5 is 10. 2 and the 4 cancel, so I have 2 times 3 is 6. And then I finished it off by substituting 2x minus 1 back in place of u. Do you guys have any questions? Today is the 16th. Yeah, it is not Tuesday. I got in late. I'll fix that in a minute. Go for it. Yeah, I'm supposed to repeat the question. The question was, what is today's date? The answer is the 16th. All right. All right. No questions? You guys are ready to discuss the next one? Brown. Brown is such a beautiful color. Okay, so what did you guys do on this one? We've got the antiderivative of x minus 2 times the square root of x plus 3. Okay, so you rewrote it. Got rid of the radical and wrote it as an exponent, I'm assuming. So we could think of this as the integral of x minus 2 times x plus 3 to the power of 1/2. So what did you let u equal in this one? What'd you try? X plus 3? Okay, let's see where that takes us. So then du would be equal to 1 dx. Again, that intermediate step, du dx equals 1, and then move the dx over, right? I'm just kind of skipping that step in between. Y'all okay with that? Du dx equals 1. When I multiply both sides by dx, I get that. What in the world are you doing? You're going to have to do this on your own in a minute, just so you know. Okay? So then we have u to the 1/2 du, but then we have the same problem that we had before. We've got this x minus 2 that we haven't changed. But we do know that u is x plus 3. So then x would be u minus 3. So we can substitute u minus 3 in place of this x. So we have u minus 3 minus 2 times u to the 1/2 du. So we have u minus 5 times u to the 1/2 du. And now we can get rid of the multiplication here by simply just going ahead and multiplying. Let's distribute. So we have u to the 1 plus 1/2 is 3/2 minus 5 u to the 1/2 du. Good with everything so far? And now we're ready to actually integrate. We've got it set up so that we can evaluate that. So if I add 1, oh, I don't know why I put that integration. We're actually performing the operation, so we don't want to write the sign now. So I have u to the 3/2 plus 2/2 is 5/2 divided by 5/2 or multiplied times 2/5. You guys okay going straight to that step? Again, if you're not okay going straight to that step, write the intermediate step in between and then simplify until you are. And then we have 5 times u to the 1/2 plus 2/2 would be 3/2 divided by 3/2 or multiplied times 2/3 plus c. So I have 2/5 u, which is x plus 3 to the 5/2, minus 5 times 2/3 is 10/3 u to the 1/2, or I'm sorry, u to the 3/2, x plus 3 to the 3/2 plus our constant. And just like all of our antiderivative problems, we can check that by taking the derivative, working backwards, making sure that we get back to x minus 2 times the square root of x plus 3. Do you guys have any questions about this example? Yes. How did I get the 2/5? So I have this intermediate step here. Remember that when I integrate u to the 5/2, I divide by that same exponent. And dividing is the same thing as multiplying by the reciprocal. So I just kind of skipped that intermediate step. For now, if you need that intermediate step, write it. Eventually you'll get to the point where you won't need it as much. But if you need to see that for now, whenever you're working these problems in a minute, go ahead and put that there until you're comfortable eliminating it. Any other questions?